Hello, my name is Mangesh Budkule. I am a senior solution architect here at AWS. In this video, I want to show you how to enhance the Amazon EBS snapshot performance using Fast Snapshot Restore feature. So before we talk about Fast Snapshot Restore feature, it is important first to understand what is a EBS volume initialization. Example, when you create a empty EBS volume, it receives maximum performance. The moment that they are created do not require any initialization. So question is, when you need volume initialization. When you create a EBS volume from a EBS snapshot, the data from EBS snapshot is a lazy loaded into EBS volume. If the volume is accessed where the data is not loaded, the application accessing the volume encounters higher latency than normal while the data gets loaded. One of the methods to avoid initial performance hit in production environment while accessing the volume that were created from the snapshot is to initialize all the blocks of the Amazon EBS volume. This is done by pulling down the storage blocks from Amazon S3 and writing to the volume before you can access them. This process is called EBS initialization as shown in this diagram. With the EBS volume initialization, the volume does not deliver the provisioned performance until it is fully initialized. For larger EBS volume, it can take many hours. Customer does this all the time. It is a free and they can use it for volume creation and restorations. The most of the application repaying the initialization cost over the lifetime of the volume is acceptable. To avoid this initial performance hit in production environment, you can use a feature called Fast Snapshot Restore feature. So FSR, you can enable it for a new or existing snapshot on per AZ basis and then create a new EBS volume that deliver the maximum performance and do not need to be initialized. When Fast Snapshot Restore is enabled for a snapshot in particular availability zone, the bucket-based credit system governance the acceleration process. Creating a volume consumes credit. The credit refill over the time. The number of volumes that you can restore with the full performance benefit of Fast Snapshot Restore is determined by the volume creation credits for the snapshot. The Fast Snapshot Restore must be explicitly enabled on per snapshot basis. Now let's jump into AWS console and see it all in action. For demo, I have a one Windows EC2 instance called FSR demo server with 1.5 TB volume. So if I go to volume, it's a 1.5 TB volume and I have a provisioned IOPS 5000 and the provisioned throughput 500. And if I select this volume, you can see this volume is not Fast Snapshot Restore enable. So this is the volume attached to this instance. Now I have connected to this instance using SSM connect and I'm going to use a flexible IO test and start reading the whole root volume of the instance for benchmarking the IO load and its bandwidth. The command I'm executing the 32 threads. Each reading block size is 128 KB sequentially from this mounted EBS volume, which is not snapshot restore enabled. There are few parameters to observe here. One is the read bandwidth and IOPS, and the total time it takes almost 3 hours to initialize whole. And you can see its IOPS is variable, but it's decreasing. And so one more parameter I'm interested to show you is not just IOPS and bandwidth, but latency also. So let me go to the volume. So you notice when I executed the flexible IO command, the average bandwidth was somewhere in 106 Mbps. IO is 982 and read latency is 49 initially and at 37 milliseconds per IOPS. So if your use case has a requirement where EBS volume needs to instantly deliver all their provision performance after creation from the snapshot. Then you can enable Fast Snapshot Restore feature on that snapshot. So I am going to do this using AWS CLI command. You can see this is the enable Fast Snapshot Restore command, availability zone which you want to enable, and the snapshot on which you want to enable this feature. Let me show you how you can enable this using console also. So this is the snapshot which we want to enable. So you just go to the select the snapshot, go to manage Fast Snapshot Restore feature, select the availability zone where you want to enable this, and just say enable. So when you are enabling this, it will go from the different stages. So you can say this is now going from the enabling stage, which is nothing but a request was made to enable the Fast Snapshot Restore, and after that it will be in optimizing state, where when it is in optimizing state, you can see this is one optimizing and one enabled. So it's nothing but it takes 60 minutes per TB to optimize the snapshot, and the snapshot in this state offers some performance benefit when restoring the volumes out of this snapshot while it is in an optimizing state. And let's go back to console, and if I want to see now the overall status of the volume, whether I can have a CLI command which I can just run, and you can see now it's an enable state, which is the state means snapshot is ready to use. So now the optimization is completed. I am confident that this snapshot is ready and don't require any initialization. So let me replace my root EBS drive for this instance with the snapshot which we have created. So let me go back to my console, and now I am just replacing my root drive. It's pending state. It takes nearly 2 to 3 minutes. The session will get disconnected, and it will replace the root drive with the snapshot which we have Fast Restore enabled. So I'm going to pause the video here, and I will come back to video once this root volume get replaced with the snapshot. Now let's see the status of the replacement volume, which this is just describing the volume, root volume task which we have initiated, and it is succeeded. So let's connect back and run the flexible IO test and start reading the whole root volume to check the performance. So we are comparing this with the previous snapshot which was not Fast Snapshot Restore enabled. So let me run now this flexible. It's the same command with 128 KB block size. So same parameters we'll observe. So you can see here now instantly it is able to deliver the bandwidth which is nearly 500 Mbps, and IOPS which is 4000 plus IOPS, and the ETA is also showing very less. So go back to the volume. This is the new volume from that snapshot. So you can see now this snapshot is Fast Snapshot Restore enabled. And if I go to monitoring, now the third parameter we want to check is latency. So in this test, you notice that we have achieved expected volume performance, almost 500 Mbps bandwidth. Read latency is very low, which is almost 0.67 millisecond per IOPS, and read IOPS was saying almost near 4000. So conclusion is Fast Snapshot Restore feature enable you to restore the multiple EBS volume from a snapshot without need to initialize the volume yourself. I have also demonstrated how FSR help in ensuring that the restore EBS volume is fully initialized at the time of creation, so it can instantly deliver the provision performance as we have seen. Some of the use cases where FSR is helpful are virtual desktop infrastructure, backup restore use case, dev test volume copies, or if you want to reduce the boot time, you can use FSR enable snapshot to create the AMI out of that. So that's about it. I hope you have enjoyed the video and thank you for your valuable time.